Hi, um, we are Group 5 and we are going to present our data analysis of the transportation company Cargo 2000, and we are going to introduce individually. So my name is Binay Jaswal.
My name is Kyle Helgeson.
I'm Caitlin Kellen.
I'm Morgan McDougall.
Alright, so the outline for our presentation that we are going to follow is first starting the challenges, explaining our methodology and research question. We will then move into our finding and the conclusion.
The challenge is to use the Cargo 2000 transport data to find the leg that has the most bottlenecks and delays within the transportation process. The methodology that we used for the R platform, and the data was provided by Cargo 2000. The research question that we came up with is, what transport leg for Cargo 2000 has the most delays?
Some of the findings that we were able to discover through our analysis was the correlation between incoming and outgoing legs overall, along with breaking down the legs to segments and finding the correlation of RCS, RCF, DEP, and DLV. We also found the differences among all four legs' planned and effective durations, along with using the top 5 largest delays in Transport 2 to classify the data. This table shows the average delay times for Transport Leg 2. We were able to find the averages of the top 5 largest delays within each segment, and this is what Leg 2 averages were. We are showing the averages of DEP and RCF because these were the segments that had the largest averages. As you can see, this table is also shown as a heat map, showing the largest delay in the deepest red and the smallest delay in the lightest red. As we can see, the departing segment 1 has the most delays, and we found that this is the segment that Cargo 2000 should really focus on in order to be able to reduce the delays and bottlenecks within their transportation process. We want to look deeper into the segment to see what is causing such large delays.
In this regression model, we were able to see the correlation and the scatter plots within Transport Leg 2. As we can see, the correlation between the effective and planned durations are very low in this segment, which shows that the delays are very high when we compared to the other transport legs. As we researched each leg, we found that Leg 2 has the lowest overall correlation, leading to our conclusion of it having the most delays and bottlenecks, and it being the leg that Cargo 2000 should focus on when trying to reduce delays. In conclusion, we found that Cargo 2000 should focus on Leg 2 to increase productivity and decrease bottlenecks. Focusing on the efficiency of this leg will make the incoming and outgoing transports run more smoothly, all while saving time, resources, and money. We also have a couple limitations that we want to also make note of. Obviously, the time constraint and our basic knowledge of R was a constraint. But with the data, looking back on it, we wish we would have used a classification that was a little less biased, using a random sample instead of the top 5 largest delays. Thank you, and our references are to follow.